Good morning, my dear students. Today I am going to explain you application of derivative, that is equation of tangent and normal drawn at any point of a given curve. So see, if y is a function of x, if y is a function of x, or if you are given any curve, for example, suppose you are taking a curve. Suppose this curve is given here. This is x, along this it is y origin. Okay. So first of all, suppose this is a curve, and at this point, suppose you have to draw a tangent. This is a tangent. Okay. So at this particular point, suppose its coordinate is x1, y1. Okay. So at this instant, at this point of x1 and y1, coordinate of this point is x1, y1, and this line is your tangent. So what is slope of this tangent? How will you calculate slope of a tangent? As you know, if y depends on x, then the variation of y with respect to very small variation in x, it means dy by dx. See, what is this? This is the first differential coefficient showing that the change in y with respect to very small change in x. So this is showing you slope. What is this? This is your slope. So slope of a line or slope of tangent drawn at any point. And now at that point, what will be slope? Slope at x1, y1. Means just find first differential coefficient of the given function. Thereafter, put into that one the coordinate at which you have to calculate equation of tangent or equation of normal. Okay. So this is your dy by dx at a particular point. Suppose x1, y1. So this is the slope of tangent drawn at a point on the curve x1, y1. Okay. Now, as you know, equation of a line passing through one point, let x1, y1 is given by y minus y1 is equal to mx minus x1. This is the equation of a line passing through one point, that is x1, y1, and its slope is m. Thus, for this equation of tangent, so therefore, equation of tangent will be calculated by equation of this tangent means y minus y1 at this point. So y minus y1 is equal to slope of this tangent. What is slope? Just see, dy by dx at that point. So slope of the tangent, that is dy by dx at that particular point x1, y1 into x minus x1. So this is the formula to calculate equation of a tangent drawn at a point x1, y1 on a curve y is equal to fx. Now if you have to calculate equation of normal drawn at any point of the curve, then just see. Since the normal drawn at this point to the tangent, this is your tangent and this is your normal. Just see, this normal and tangent both are mutually perpendicular. So if its slope of tangent, slope of normal Then what is relation between slope of normal and slope of tangent? So slope of tangent into slope of normal will be equal to -1. Yes or no? Okay. Since these both of the lines, tangent and normals, are mutually perpendicular, therefore slope of tangent into slope of normal will be equal to -1, and hence since slope of tangent is known, therefore slope of normal will be equal to -1 upon slope of tangent. By using this relation, this will be equal to -1 upon slope of tangent. What is slope of tangent? This is dy by dx at a particular point x1, y1. Okay. In this way, this is your slope of a normal. Slope of normal drawn at this point. Now, slope of normal is known. Thus, equation of normal here I am writing. Therefore, equation of normal drawn at x1, y1, will be equal to y minus y1 equal to -1 upon dy by dx at x1, y1 into x minus x1. This is your equation of normal drawn at a point x1, y1 to a given curve. Now let's solve some examples. Okay. One numerical, that is, find the slope of the tangents to the following curves. Y is equal to x cube minus x at x is equal to 2. Okay, some questions are: find the slope of a curve given y is equal to x cube minus x at x is equal to 2. Okay, just see. What is slope of tangent? Slope of tangent is dy by dx at that particular point. So, first of all, you need to calculate dy by dx. Step 1. Calculate dy by dx. So, you will find 3x square minus 1. Okay. Now, dy by dx at x1 and y1. It implies that. Now, second step 2. Put the coordinate here dy by dx at x1 and y1. x1 is 2, means the point at which you have to calculate. And y1, even no need here, but you can find y. If x is 2, then what will be y? If x is 2, then y will be equal to, put 2 in original equation, 2 cube 8 minus 2. What will you get? 6. 2 cube 8 minus 2, 6. So at 2 comma 6, this is x1, this is y1. So for at 2 comma 6, dy by dx will be equal to, here putting 2, 2 to the 4, 4 3 the 12 minus 1. So it will be 11. Or once you can put 3 into 2 square minus 1. So 12 minus 1. This is 11. Okay. So it implies that dy by dx, that is slope of tangent at 2 comma 6 is equal to 11. This is your slope. Another question. Find the equation of the tangent to the curve x square upon a square plus y square upon b square is equal to 1 at x1 y1 at x1 y1. Find equation of tangent. Find equation of tangent. Now see how will you find. First step is that calculate dy by dx. So differentiating both of the side, what we get? Here 1 upon a square 2x plus 1 upon b square, here 2y dy by dx is equal to 0. Is it so? Alright. So it implies that dy by dx into 2y by d square is equal to minus 2x upon a square. This 2 and 2 cancel out. It implies that dy by dx is equal to this b square upon a square x upon 1. It implies that dy by dx at x1 y1, since at the point where you have to calculate equation of tangent, you have to find equation of tangent, at that point you have to calculate slope. Thus dy by dx at x1 y1 will be equal to, putting at the place of x x1 and at the place of y y1, so minus b square upon a square x1 upon y1. So this is your slope of the tangent. Slope of the tangent. Now equation of tangent. Okay, at x1 y1. So y minus y1, m means slope, minus b square upon a square x1 upon y1 into x minus x1. Okay. Now you can solve it. How you solve? By cross multiplication. See, this a square y1 y minus a square y1 square, okay, is equal to minus b square x x1 plus b square x1 square. Is it so? It implies that, now see, this a square y1 and this term will come this side, so plus b square x x1 is equal to b square x1 square plus a square y1 square. Dividing both of the side by a square b square. A square b square. Dividing both of the term by both of the side by a square b square, what we get? From here this is cancelled out, here this one cancel out, here this one cancel out, here this one cancel out. So what will you get? You will get as x x1 upon a square plus y1 upon b square is equal to, see, x1 square upon a square plus y1 square upon b square. Just like if this curve is having this point, so this point will satisfy to this equation. Hence, at the place of x and y, if you will put x1 and y1, you will get x1 square upon a square plus y1 square upon b square is equal to 1. So, putting at that place as 1. So, this is your required equation of tangent to this curve at this point. Got the point? Alright. In this way, you can solve all the questions from examples and from exercise as well. Thank you so much.